Everybody, and welcome to Weather Part 3. Why do we have weather? Because? Let's find out, shall we? The greenhouse effect. That's why we have weather, kind of. You see, but the greenhouse effect is a rather important thing that we have here. You see, the sun's light shines on the planet Earth, but we knew this already, didn't we? Now, some sunlight is reflected back into the space from the clouds. But our atmosphere also traps some of the heat. And it is this trapping of the heat that is called the greenhouse effect. Without the greenhouse effect, the Earth would lose all of its heat. The Earth would be a really cold place to live. You see right here, we're on the front side, and we're getting all the sunlight. But on the dark side of the planet, it's getting really dark. And without the sun, without the heat, it gets really cold really quickly. And without this greenhouse effect, without this layer of the atmosphere, it's kind of like a blanket. And it keeps the heat in at night, and it keeps us warm. And this is a good thing. The sun heats the Earth unevenly. This is the second reason why we have weather. As you can see, down here at the South Pole, it's really bright and sunny. But up here at the North Pole, they're not getting any light at all. It's a dark day. Southern Hemisphere getting all the light. Northern Hemisphere gets much less. This, great if you live in the South, not so great if you live in the North. And because of the air around the Earth heating unevenly, this creates large bodies of air at different temperatures. These massive bodies of air as known as air masses. Who knew, right? An air mass is a large body of air that has similar temperature and moisture properties throughout. What is that? Right here. Those words in big, boldface, underlined. What a great time to hit pause, kind of slide over on your screen and write the words in Shobi on the worksheet. Subtle hint. Last one you get. Big, bold-faced, write it down. Here we go. Happy part is you can always rewind, right? There are two basic types of air masses. The warm, moist air masses and the cold, dry air masses. Now, warm, moist air mass forms in the tropical regions of our planet close to the equator, down here in what we call the tropics, usually over water. Cold, dry air masses form closer to the north or south poles and usually form over land, or in this case, ice. When these two types of air masses meet, they create weather. The boundary between two air masses is called a front. So if you're looking on this map here, you got cold air here, you got warm air here, and right around this boundary, you have a thunderstorm. But over here, on the other side, we have another cold air mass and a warm air mass, and this is just creating some nice rain. Okay. When our cold air and warm air mixes it up, this of course changes the temperature of the air, which of course decreases the amount of humidity that air can hold. So what it can hold in the terms of, or what the air can't hold in terms of water vapor condenses into rain, or what we might call, starts with a P, rhymes with precipitation. Precipitation. Now, a cold front is defined as an area where a cold air mass is replacing warmer air masses. Okay? And if you look along the boundary here, you've got this cold zone, and then above it you have this warm zone of air. Now, a cold air mass sinks, right? Cold air falls and hot air rises. So when a cold air mass comes along, it kind of acts like a bulldozer, and it just plows that warm air right on over the top of it, just like my hands. That's pretty impressive, wasn't it? That's high tech right there. But nonetheless, it just kind of snow plows or bulldozes that warm air above it, which of course makes all this rain form. Usually this is where we get our thunderstorms and our more, shall we say, obnoxious weather. Cold fronts generally move from the northwest of our country towards the southeast, and the air behind the cold front is noticeably cooler and drier. As you can see here, we're at 38 degrees, and in front of it, 55 degrees. It's not a bad day there in whatever state that is. What state is that? A cold front is represented by a solid line with triangles along the front, pointing in the direction of movement. And it's colored blue. Coincidence? No, it's not. Little triangles here showing us which direction this front is expanding upon. Also labeled by two ginormous H's for high air pressure. And you'll note right here in front of it, a big storm. Coincidence? No, not at all. Now, a warm front. This is defined as a transition zone where the warm air mass, I can read really, a warm front is defined as the transition zone where a warm air mass is replacing a cold air mass. Now, as the warm front comes in, it just kind of acts like a big angled shovel. And again, the cold air is down here, but that warm air mass just comes through and it just pushes the cold air right out of the way. So everything behind it's nice and warm and happy, everything in front of it nice and cold and miserable, and right here, usually a big line of rain. These are generally not your thunderstorms. These are generally your soaking rains, the days that it just kind of rains all day and just no thunder, no lightning, no fun, can't go out and play, and it's just raining all day long. Warm fronts generally move from the southwest to the northeast, and the air behind a warm front is warmer and more moist than the air ahead of it. When a warm front passes through, the air becomes noticeably warmer and more humid than it was before. A warm front is represented by a solid line with half circles pointing towards the colder air and in the direction of movement. So again, where we had blue triangles on the cold front, the warm front gets these little red half circles, again showing which direction they are moving in. And of course, on colored weather maps, the warm front is drawn with a solid red line. Our friend Hal is here, which means it must be quiz time. Because who doesn't like a quiz at the end of a lecture, right? Woo-hoo! Here it is. It is your quiz right here, right now. What I want you to do, hit pause, do the quiz. I'll move my little face somewhere where I'm not going to be in the way. I'm in the way everywhere. Look, it says the Earth. Okay. Sorry, I can't get myself out of there. Oh, there, I'm gone. Look at that. Go ahead and do your quiz right now. Hit pause and unpause when you're done. You done yet? What about now? I'm back. Okay, here we go. True or false? I'm gone. True or false? Without the greenhouse effect, the Earth would be a very hot place. True. False. I got you. I got you. No, it would be very cold, in fact, without the greenhouse effect. Remember, it is a big warm blanket of air that covers our planet, keeps us nice and warm. Number 2, true or false? A front is a large body of air that has similar temperature and moisture properties throughout. False. That, of course, is not a front. It is an air mass, but you knew that already. I know you did because you were paying attention. Number 3, true or false? When two air masses meet, it is called a front. As opposed to a back? Yeah, that is true. Number 4, true or false? Cold fronts form in the warm tropical regions of the world like Florida. No. False. That's warm fronts. And number 5, true or false? When a warm air mass replaces a cold air mass, this is called a warm front. True. How'd you do? Good? Did you get all 5 right? Good job. If you missed 1, 2, all 5, you might want to go back and watch this again. Make sure you're clear on the concepts because, hey, this is the wonderful world of video and we can rewind. Who knew, right? Thank you all for watching. Have a wonderful night and we'll see you next time.